and we'll see how when the kids join, we will. But in today's class, while I am tempted to teach you guys something new, I first wanted to see if you guys had any question with respect to what we learned in the previous class. No questions? Anybody having any struggle with the assignment that we were trying to do?
Sir, I had the problem with the theorems.
Okay. You had the problem.
Yes.
You had problem
Yeah.
with it. Okay.
Yeah, so I was a little confused.
A little confused. So we'll probably spend 5 minutes to go through 5 or 10 minutes to go through it, so that we understand the concept. We will not try solving it. We will not try kind of redoing the theorem, because that is something that you guys have already learned, and we already have a video of that which you can watch and kind of revise. And if you are still confused, let me know. We can certainly do that. One thing is for sure, if there is any concept that we learn in the class and you have not understood it, I can teach it 5 times, 10 times, don't worry about that. I don't get tired teaching, okay? Only thing is, just because we are also recording the video of the class, that gives us the ability to kind of do an offline review, go through it one more time, see if there's something that is confusing still, and then you come back to me, okay? So that's how we'll do. But for today's class, let's spend 5 to 10 minutes to go through what we have learned. It will be more like a recap, and then we will see if that is working. If not, I will request you, Siddharth, to just go through the video of the last class one more time. Take a note, pen and paper, just note down whatever I'm saying. From that, whatever is the key message, right? Note it down. And then try building your understanding and come back to me if there is something still confusing, okay? Because the thing with math is, there's only one way to solve. There's only one way to learn. And that is by doing it. Okay? So when you get stuck, that means you have to do. When you get stuck, it means you have to do it one more time. If you further get stuck, try doing it one more time. That's how it is. It's not about memorizing it, it's about understanding it right. Okay? Hi Pranav. Alright. So what we are trying to do first is just do a quick recap of what we have learned so far, and then we will come to the next thing that we want to learn. So we learned about theorem of congruence for triangles. And when we say congruence, whenever we say that two triangles are congruent or two shapes are congruent, that means they are exactly the same. They are exactly the same. Now in geometry, when we say something is same, the only meaning of that is they have each and every property matching. Okay? Let's say if I say I and Siddharth are congruent, what that means? My and Siddharth's height is the same. If I am wearing glasses, Siddharth is also wearing glasses. If I have 2 hands, Siddharth also has 2 hands. If I have 2 legs, Siddharth also has 2 legs. And the length of the legs are also the same. That's the only way I and Siddharth can be congruent. Okay? I know the example is not right. I and Siddharth cannot be congruent. I am way too old for Siddharth to be congruent with me. But still, that's the theory part of it. Now, so in the process of saying the two triangles are congruent, the outcome is that every property is matching. The 3 sides of one triangle is matching with the 3 sides of the other triangle. 3 angles of this triangle is matching with the 3 angles of the other triangle. That is understood. But will you always match each and every side, each and every angle? No. Because there are a lot of derived information that we can use or leverage to keep it simple and easy for us. And that is where these theorems come into play. And this is essentially where we learn these theorems. SSS, SAS, ASA and RHS. These are the 4 theorems that we learn. First theorem is SSS, which says if the two triangles have 3 sides matching, meaning one side of one triangle is matching with another side, one side of other triangle. Second side of this triangle is matching with the one side of the second triangle. Third side of this triangle is matching with the third side of other triangle. If the two triangles have matching sides, they are congruent. And why? Because you will never ever be able to draw two different triangles with the same dimensions. Yes, Amoga?
Can you show us an example, like a triangle, like two triangles together? Can you show us how they are?
So if these are two triangles, okay? If this is 5 centimeter and this is also 5 centimeter. This is 6 centimeter. This is also 6 centimeter. This is 8 centimeter. This is also 8 centimeter. What I am trying to say is, if the three sides have corresponding matching sides in these two triangles, they are congruent. And I am not going to show you because this is one challenge that I had given in the last class, saying, can you draw two triangles with the matching dimension but they are different? And you will not be able to. You will never be able to. Because, let's say if I am giving you to draw this triangle, what will you do? You will draw, let's say, 6 centimeter line. A line segment of 6 centimeters. You did this. Then what will you do? You will make one arc. There is a compass that we use for drawing circles. So make it 5 centimeter long and draw a circle. This is what you have drawn. Now, this is 8 centimeters. So from this place, make an 8 centimeter arc and draw a circle. Okay? You will see that these two circles are cutting each other at 2 points. Are cutting at 2 points. And this is the only two triangles that you can draw. You will not be able to draw a third triangle actually. And these two triangles are just a mirror image of each other. So that is the reason it's a practically given scenario that you will not be able to draw two triangles with the matching dimension, which will be different. Only thing you can do is, instead of doing base, you can say, okay fine, I will draw my base as 8 centimeter. That's fine. If you draw your base as 8 centimeter, what will you do? From this point, you will say a circle with 6 centimeters. And from this point, a circle with 5 centimeters. Draw it. You make two triangles here also. But actually, if you look at this, these two triangles are exactly the same. It is just like alignment is different. Here your base was this, now your base is this. So you are just flipping the triangle, that's it. Nothing is changing. So that's the reason why I was not proving it. It's a what do you call it? It's called a universal truth. There is no way you can change it. Okay? Are you guys with me? Okay? Alright. So that is why I was saying that we don't have to prove this one. This is a universal truth. So nobody has proved this ever, and there is no need to prove it because this is the basic method for drawing the triangle. Yeah? Okay? So far so good? Everybody okay with what I said? Everybody okay with what I said? No confusion? Okay. Alright. Now, so this is the first theorem that we learned. What is the second theorem? That is called SAS. If I have two triangles where this side is equal to this side is equal to this side, and the angle between them are matching, then these two are congruent. Okay? So this one also we saw in the previous class. How do you prove it? That if these two sides are same. Just 1 second. Hello? Okay. So if the two sides are same, I am using these two sides to make this angle. If these two sides are same, my distance here, this distance and this distance will be the same. So these two sides will match. if you can remember, I would say, okay, let's say this is 5 centimeter and this is 8 centimeter. This is 5 centimeter. This is 8 centimeter. This angle is, let's say, 40 degrees. This is also 40 degrees. Now, if I draw an angle of 40 degrees with 5 centimeter and 8 centimeter, this is my distance between these two lines. This is my third line of the triangle. Now, if I try drawing 5 centimeter and 8 centimeter, and this is 20 degrees. This is 5 centimeter and this is, let's say, 8 centimeter. See the distance between the two edges. Just because the angle was small, the distance became smaller, right? So, if I make it like this is 5 centimeter, 8 centimeter. This angle is 130 degrees, let's say. Now you look at the distance between this corner and this corner. See, when my angle is becoming bigger, my distance between these two end points is becoming bigger. When the angle is becoming smaller, the distance between the two end points is becoming smaller. So if the angle is same, this distance will be the same. So here the two sides are same and the angle will be same. By no means this side and this side will be different. Yeah? You understood? So that means the three sides are same now. If the three sides are same, then this one applies any which way. Yeah? So this theorem is also done. So this is what we learned. And good that it's okay to learn certain things couple of times rather than assuming that I learned and I still have some doubts in mind. So let's spend 5 more minutes, we'll be done. Then the third thing that we did was this. So I'm saving you 1 hour of watching video, okay? So we are just doing the revision here itself, okay? Alright, now, and that will help everybody. So whoever had smallest of doubt, then will get clarified here. So now the third theorem was ASA, meaning if I have two triangles where this angle and this angle, this angle and this angle, so this is same as this and this is same as this, and the side between them, these two are matching, then these two are congruent. Now here we know that any triangle, sum of all the angles is 180 degrees. This and this are same, this and this are same. Let's say this is x and this is y. And this is, let's say this is 1, this is also 1, this is 2, this is also 2. So here sum of angle x plus angle 1 plus angle 2 in this triangle will be equal to 180 degrees. Here in this triangle, angle y plus angle 1 plus angle 2 will be equal to 180 degrees. See here, if you look at these two equations, this and this are same, this and this are same, and sum is also the same. That means angle of x is equal to angle of y. Yeah? That means these angles are also same. Now you have all the three angles matching, one and side is matching. Okay? And then we looked at these two triangles are similar triangles. If the triangles are similar triangles, where did Amuga go? Amuga dropped off? Okay. Alright. So when the two triangles are similar triangles, the sides will be in the same ratio. Meaning this side is equal to this one, hence this side will be equal to this one because these angles are same. The side opposite to the matching angle will be the same ratio. Oops. What happened? Siddharth also gone. Okay. Siddharth is back. Alright. So this becomes a case of a similar triangle, and if the triangles are similar, the sides will be the same ratio, same proportion. So that is how if these two sides are matching, then the other two sides will also be matching. And when we find the two sides are matching, that means it qualifies for SAS any which way. And here also you can say, okay, fine, these two triangles are similar triangles. You take the ratio of the sides matching or opposite the matching angle, and then you will find that all the three sides are matching. So if the sides are matching, it becomes SSS theorem. That is a universal truth. So this one is also right. And then we learn another variation of this one. Say, okay, I don't have to say have the side inside this one. It can be any two angle and one side. Because if two angles are matching, third angle anyway is matching. So it's done. So we don't have to say ASA, we can say SAA or AAS, whatever it's fine. Yeah. So this one also we learn. Everybody clear? Everybody? Yeah? Okay. Now comes the next one. Next one is RHS. And this RHS is for right angle triangle. Which says if the hypotenuse of the two right angle triangles are matching and one of the sides, let's say this side and this side are matching, then these are congruent. But if you guys recall the Pythagorean theorem, which we had proved in one of the classes, hypotenuse square is sum of this square to this square, and if this and this are matching, to this will be matching as well. Yeah? So then that translates to SSS kind of scenario. So these are the four theorems that we had learned, and all the assignment that I had given you guys was just to reflect on these four theorems that we had learned. There was nothing difficult about those assignments as per my understanding, but if you have any doubt, I'm certainly open to take up those questions and see if I can explain that how it should be done. Everybody is clear? Assignment was easy? Okay. And trust me, that is my guarantee also. Whenever I'm giving you guys assignment, the assignments have to be easy, provided I have explained the concepts right. And you have followed me or you have paid attention in the class. If you are able to pay attention in the class, trust me, the assignments now and always will be a cakewalk for you. That is my guarantee to everybody, okay? And my assignments will never ever bother you. It is something that you will be able to finish in 5 to 10, a maximum 30 minutes, that's it. For the whole week, I am not giving you guys assignment more than 30 minutes. I want you guys to enjoy the math rather than being stressed out. Yes, Amoga.
My mom was wanting me to check the homework.
Yes, I check the homework, but I don't get time to check each and every homework because I always ask the kids to do the homework and explain to their parents. So that way, when they are explaining to their parents, parents would know, or parents would be able to see, okay, my child has understood the thing or not. When you are explaining to somebody, right, let's say you give me a tough question to solve, and if I don't know about it, trust me, I will fumble. I will struggle to explain that. So that is the reason why I asked you guys to explain. When you explain to your parents, that time you would also know whether you have understood this or not. And if you fumble, that's an opportunity for me. That's when your parents will come to me saying, okay, sir, regardless of whether you have seen the homework or not, I was not confident when my child was explaining the sum to me. That means something needs to be taught again, and that is when I will do that again. Okay? So don't rely on me for solving, for validating or checking all the assignments. I don't do it religiously because I'm leaning on parents to give me feedback. Okay? All right. Yes, Siddharth, you were saying something.
Sir, I forgot to write the answer on the paper.
So it's okay. One day you forgot, that's fine. Now since you know, see, I love the fact that you said that you forgot. That means you know where the problem is. And if you know the problem, it's easy to fix. So even if you forgot, you did not do it, do it. Because no, it's a more of a playful act, right? You know something, you're just trying to do something. Take a printout of that, mark the theorem that is applicable for those scenarios, and show it to parents. Say, okay, last week I forgot, just check it if I'm doing it right. And this is how I'm doing it. When you explain that to your parents, they will know whether they have to ask me for teaching it again or not. Okay?
Sir?
Yeah?
We just moved right here, so we don't have a printing machine, so...
That is okay then. So you're joining from a laptop or from a phone, right? So in that laptop. So in the laptop, you can just open that sheet and probably just mark. Take a pen and paper and just say, okay, question number 1, this is my answer. Question number 2, this is my answer. That is also fine. See, ultimately you have to look at the. You can also draw the triangles. I mean, whatever is on the sheet, right? Just draw it and say, this is my answer. You see my drawing skills. I'm not a great guy when it comes to drawing, right? That's fine. You just draw it the way you are comfortable and then just mark the answer. Ultimately, if you guys are confident, my confidence level goes up many folds. If you are not, I'll end up stopping whatever I'm doing right now. Yeah? Alright. So everybody's clear? Everybody is bothering their parents as well, showing the assignment, explaining them. Okay. Please keep doing that because that's my only, that's my only way to make sure that whatever I'm teaching you guys is actually reaching you guys. Yeah? Okay. Now, what do we want to learn today? We still have 40 more minutes. We did a recap of the theorem that we had learned. So let's try. Did we learn how to find out the area of a parallelogram? Yeah, we learned. Now let's learn it in a little different way. Let's learn it in a different way. Because we have learned about the... Okay, tell me one thing. Are you guys very clear about the parallel lines and the angles between them? If you have a third line intersecting them? Siddharth is clear. How about Pranav, Amoga, Sherry? Everybody is clear? Okay, let me ask you some questions because this is related to what I'm going to teach next. So let me just do a quick check, okay? If let's say this is angle 1 and this is angle 2 and this is angle 3 and this is angle 4, this is angle 5, this is angle 6, this is angle 7, this is angle 8. Now tell me, angle 2 plus angle 4 will be equal to how much? Angle 2 and angle 4 will be equal to how much? I'm sorry?
Can you repeat the question?
Yeah, I'm saying these are two parallel lines. This is this and these are two parallel lines. This is the third line which is intersecting them. And that makes these 8 angles as you can see. Yeah? I'm asking you guys, what is the sum of angle 2 and angle 4?
6.
Sorry? No, I'm saying this is 180, okay. That's what. Because these are names of the angle. 2 and 4 are the names, okay, not the value. So 2 and 4 is 180. Do you guys know why?
Because all of the lines are like straight, so the corners will be right angles.
Okay, let's see what Cherry has to say.
Since the lines meet, the angles will be 90 degrees, and if they combine into 90 degree angles, they get 180.
No, little louder.
Since the line meet, the angle has to be 90 degrees. If we add two 90 degree angles,
No, these are not 90 degrees. Don't assume this is 90 degree. I never said so. So okay, let me make it even more explicit for you guys. Amuga, I'll come to you, okay? So these are my two parallel lines, okay? And this is the line that is intersecting it. Now this is, let's say, 1, 2, 3, 4. This is 5. This is 6. This is 7. And this is 8. Now I'm asking you, tell me angle 2 plus angle 7. And I'm giving you guys a clue that this is 180 degrees, that you are right with your answer. But how part is what will make sure that we get it right. Okay, Yamoga, you were saying something.
Is it because it's a straight line? It's really the difference?
This is a straight line, but this line is here. This line is here. If I have a straight line like this, and then this plus this will be a 180 degree, I understand. Even if I have like this, so this plus this will be 180 degree. That is understood. But here this guy, this angle is made on this corner with this line, and this line is this angle is made with this line on this corner. So, yeah, Pranav.
So like, if we add like two angles, it's going to be like 180. So like, if the sum of the two angles will be 180.
No, so sum of two angles will be 180 in this scenario. This is my horizontal line. If there is a third line which is catching it here, then this angle plus this angle will be 180 degrees, because this is 180 degrees, straight line. That much understood. I am talking about this angle here and this angle here. See again, look at this. This angle is made on this corner, this angle is made on this place. There is no relation between these two guys. If you compare it with this scenario. Yes, Siddharth, you are saying something? No? You are doing something. Okay. So, okay. Yeah, Amoga, you are saying something?
Yeah, so is it because in the picture and in the 180 degree picture on the top, it's like the same exact as the one on the...
Right. So this has something to do with the property of the parallel lines. Let's look at those properties, because we learned about, let's go back to parallel lines, because that's kind of important. Okay, let's spend some time, and then you'll be able to relate to what I'm trying to say and how you can derive it, and you'll be very clear next time when you have to explain this further. Okay. So now let's look at, when we say parallel lines, what we know about parallel lines is, here are two lines which are equidistant from each other, meaning the perpendicular distance between them at any place will be the same. They are never going to get closer or farther from each other. Okay? The distance will be the same. Okay? That's one property that we know. Now, when a third line cuts both of them, now let's look at this scenario. This angle and this angle. Will they be same or will they be different? These are opposite angles. They have to be same. If I have this line cutting this way, this angle and this angle will be the same. The inclination between them is the same. That's the basic behavior. Yeah? See, look at this. This line and this line are cutting here. To the opposite angles, this one and this one will be same always. Because if you look at, see, this is 40 degree. This is also 40 degree only. Yeah? It has nothing to do with the parallel lines, okay? When you have two lines cutting each other, these are called opposite angles and they will be the same. No matter whether you believe me or not. Okay? Any two lines cutting each other at a point, the opposite angles will be the same. This and this will be the same. This and this will also be the same. Okay? This part is clear? Everybody? Now, look at this one, this scenario. This angle and this angle are same. Because these are two lines cutting each other at this point, and these are the opposite angles. Similarly, this angle and this angle will be the same. Okay? Let me not say 40 or anything. Let's say this is 1, this is 2, this is 3, this is 4. So angle 1 will be equal to angle 3. Similarly, angle 4 will be equal to angle 2. Yeah? Everybody with me so far? Now, look at this. Angle 1 plus angle 2 will be equal to 180 degrees. Angle 1 and 2 is made on this line with this one cutting here. Okay? Everybody with me? Now angle 2 and 3 will also be equal to 180 degrees. Again, this is made on this line. Yeah? Everybody here? 2 and 3 will be 180 degrees. Same way 3 and 4 will be also 180 degrees. I'm not writing all of them, but just telling you guys. Yeah? So here you know 4 and 2 are same, 1 and 3 are same. Okay, now let's look at this guy. Let's see, this is 5 and this is 6. This is 7 and this is 8. Okay? Now, here, in this scenario, this line and this line are cutting here. So here, again angle 5 will be equal to angle 7. This and this will be the same, this and this will be the same, because these two lines are cutting here at this point. Angle 6 will be equal to angle 8. So far good? Now, same way like here we saw, 5 and 6 will be 180 degrees. Angle 5 plus angle 6 will be 180 degrees. Similarly, 6 plus 7 will be 180. I mean, I'm not writing all of them. What I had asked you guys was sum of this angle and this angle. Okay? I was asking you guys, this angle plus this angle will be how much? So, angle 1 plus angle 6 is what I was asking you to tell me how much. Now, the parallel lines property says, if I have two parallel lines and this line cuts, the angles made on the same side will be the same. This angle and this angle will be the same. These are called corresponding angles. When you have two parallel lines, these corresponding angles will be the same. So this angle will be equal to this angle. This angle will be equal to this angle. Corresponding angles are the angles made on the same side of the two lines. So this will be same as this one. Similarly, this will be equal to this one. This one will be equal to this one. Because they are the same side. If this angle is below this line, the parallel line is this one, this is below this line. If this angle is above this line, on this side of the third line, this angle is on this side, above this line. So, these are called corresponding angles. The corresponding angles will be the same. I know I created a mess here. Let me clean it up. Again, just to remember, if you have two lines cutting each other, the opposite angles of these angles will be the same. Okay? And if you are talking about two parallel lines and the third line crosses it, the corresponding angle will be the same. Meaning this angle is same as this angle and this angle are corresponding angles. Okay? They will be the same. Similarly, go to this side of the line. This angle and this angle will be corresponding angles. Both are above the line and the same side of the third line, intersecting line. Okay? This angle and this angle is the same. They are corresponding angles. They are both below the parallel lines and this side of the intersecting line. Similarly, this line angle and this angle will be the same. Both are below the parallel lines and the same side of the intersecting line. Okay? So remember two things. When two lines cross each other, opposite angles are same. That is not to be proven. That is given. When you have two parallel lines, a third line intersects them, the corresponding angles are same. Corresponding angles means the angles on the same side, above or below, same side of the third intersecting line. Okay. If you remember this one, now you have to solve this. So here, what did I say? This angle and this angle. First of all, what do we know? We know that corresponding angles are same. So this angle and this angle are same. This and this, 1 and 5. Angle 1 is equal to angle 5. That is what I know by the property of parallel lines. Now, this angle, so angle 5 plus angle 6 is how much? Angle 5 plus 6 is how much? Can anybody tell me? How much is angle 5 plus 6? Angle 5 plus 6. Visualize this. This is a straight line and you are making two angles. How much is that? 5 and 6. Angle 5 plus angle 6. How much is that?
180.
180. Because this is made on a horizontal line. Yeah? So angle 5 plus 6 is 180 degrees. Okay? Now you know angle 1 is equal to angle 5. These are corresponding angles against the two parallel lines is equal to angle 5. And you know angle 5 and angle 6 together is 180 degrees. What I was asking, angle 1 plus 6. Angle 1 plus 6. You know that angle 1 and angle 5 are the same. Angle 1 and 5 are the same, corresponding angle. So you can as well replace here. Angle 5 plus 6 is what I am asking you guys to tell me. Angle 5 plus 6 is made against the horizontal line, which is 180 degrees. So that will be same as angle 5 plus 6. Got it? Or confused? So, see, here, now, whatever I have written here, just forget everything. A very simple way. You don't have to, see, I had to put so much effort to break it down. Now, since you guys know the opposite angles are same, and when you are talking about parallel lines, corresponding angles are same. That's the only thing you have to keep in mind. Now I said, okay, fine, this one, this one. Tell me this plus this. Now look at this. This angle and this angle have no relationship. These are two stepchild. What do you call it? Step siblings. Or not siblings. Step, let's not use a controversial term. So I'm saying these two are looking neighbors, but they don't have any relationship. I don't have a relationship with any of my neighbors, right? They are just friends. There is no relationship. But this guy has a relationship with this guy because they are corresponding angles. And I know this plus this is 180 and this are same. So this and this will be same as this plus this. Yeah? So now let's play with it for a little bit because math is all about playing. More you play, more you enjoy, more you learn. And then you don't have to study. So let's play with it. Now you will see how interesting it is to find maximum information with minimum details. Okay? Let's see. If I tell you guys, I have two parallel lines and this angle is 45 degrees. Okay? Tell me how much will be 1, 2, 3, 4, 5, 6, 7. So I just gave you one angle, okay? And I am asking you to get me the value of remaining 7 angles. I am just giving you what? It's like I am giving you $2. I am asking you to get the grocery for the entire month. Yeah? Let's see if you are able to do it with whatever we have learned. This is angle 45 degrees. I am telling you to give me the value of all the other angles. Let's see who can solve it quickly. And it's okay to go wrong. It's perfectly fine. I love you guys when you guys go wrong.
The second angle is 45.
Second is 45, okay?
The fifth angle and the third angle are 45 too.
Fifth and third. Third is 45. And fifth is 45, okay? I'm just noting it down. I'm not doing any validation right now. I'm just noting down what you guys say. And you guys know this is third. This is 1, 2, 3, 4, 5, 6, 7. And if anybody wants to give a different value for any angle that is given, you're more than welcome to correct that, okay? You don't have to agree to your friends.
Sir,
Yep.
6, 7, 9, and 1 are 135.
So you're saying 6. Pranav, say that again.
6, 7, 4, and 1 are 135.
6, 135. 7, 135. 6, 7, 1, 135. Okay? 6, 7, 1. And again, I'm asking each one of you, don't trust any of your friends, okay? Like I say, I don't trust you guys. Not because I don't want to, but I don't trust you when it comes to solving math. So I will solve math my own way. Even if you say this is right, I would not trust you and I'll do it myself.
Sir, and 4.
And 4.
Yeah,
And 4 is also 135?
yeah.
Okay. Anybody has a different answer?
I think angle 4 is 45 degrees.
Louder better. Little louder.
Angle 4 is 45 degrees.
Angle 4 is 45 degrees. So this is coming from Pranav and not to the name, but angle 4 is 45 degrees. Okay. I hope this is not a very boring exercise. I want each one of you to participate, okay? Try it, try it. So, I'm giving you guys 5 more minutes, and we will. I will conclude your answers with that, and then I will do it all afresh. Some answers could go wrong, some could not, may not. And whoever has done already, I would still want you guys to review answers, okay? Because some of your answers might go wrong. And if you want to make the corrections, it's the time. Amoga, you're thinking?
I think whatever pronounced that I got.
You got the same? Okay. I mean, I'm okay you guys trusting each other, but I would not.
I solved it.
Okay, no, I'm saying, see what happens is when some, again, this has nothing to do with any of you as such. This is more of a human tendency, right? When you hear the first answer from somebody, you tend to get biased, and that's what I would ask or suggest you guys to avoid. Okay, bias is a very bad problem.
Yeah.
Let's see.
Sir,
Yep.
I think 1 and 7 are 130.
1 and 7 are 130. 135?
130.
130. Oh, I got a new answer. I'm loving it. Let's see. Okay. More the answers, more fun. Let's see. And again, see, the reason why I'm saying more answers, more fun, meaning there are more attempts happening, and when you, with the math, the thing is, see, the whole world knows the theorem as ASA. But when we were doing it, we came up with a different thing, right? We are saying different narrative altogether. Saying that no, any side and any two angles. That completely kind of contradicts that theorem or adds more color to it. Tomorrow when you guys end up solving some sums, you'll say, okay, ASA is fine, but I know that I can even prove two triangles being congruent with AAS or SAA, right? Because you have done it yourself. You have seen it in the class. So that's what I'm saying. When you do things, you might get ideas which is not written in the books. So more the answers, more possibility of creative ways of solving it. Okay, so I think 2 more minutes, okay? Then I will start. Siddharth, are you ready? Are you done? Or you want to
My answer is 130.
say that again?
My answer is 130.
130? Okay. Now let's, yeah. Yes, go ahead.
Never mind.
Never mind. Okay. Alright. So let's come to this one. I am wiping off all the answers, okay? So that we can do it afresh. In a scenario like this, now you guys will hate me for this, right? My punchline can trust, read, analyze, and then do it. Trust is something that you all do. You all trust yourself. No doubt about it. Read. We are reading the question again. Oh, we have two parallel lines. And these are the angles. I have to find out. Only angle I have given is this. 45 degrees. Okay? This is the only thing that is known. Everything else is to be found out. Then analyze. Then you analyze. You have to find what is that I know. I know that when I have two lines cutting each other, the opposite angles are same. And what I know is corresponding angles are same. When I talk about two parallel lines, I know this guy. With this guy, what all I can find out? See here, this angle and this angle are opposite angles, right? So they have to match. If this is 45, this has to be 45, no doubt about it. Done. There is one more thing that we know. If I have one line and then a line crosses this, okay, I am not looking beyond this. This plus this will be 180. Yeah? Here, I know this angle and this angle. If I look at this is a straight line. This is one and this is the other one. So this is 45. What is this guy? 180 minus 45. This is what gives me 135 degrees. Yeah? Now, I got this guy. I'm not doing anything fancy here. I'm just going step by step. This and this are opposite angles matching. I don't have to do any calculation. I form this two on the same horizontal line. This is 185. 180 minus 45. This is 135. Now this guy and this guy are opposite angles. So this is 135. This is 135 as well. Yeah? So with these two lines we have formed 4 angles. Now comes my parallel line. The only way I can relate these two, because these are 2 parallel lines. And I know if I have a parallel line, the corresponding angles are same. Corresponding angles are same. So my 2 becomes same as this guy, that is 45 degrees. If this is 45, this is 135, same thing, horizontal line. If this is 45, opposite angle is this one, 45. If this is 135, this is my opposite angle, 135. Right? So we applied three information that we had, and that is what we had to nail it down to in this stage, analysis. By looking at this question, reading this question, I know the property of parallel lines, corresponding angles will be the same. I know property of 2 crossing lines, opposite angles are same. And third property I know is if I have a horizontal line and second line cuts it, sum of the angles is 180. Enough. That's what we need. It was a child's play. And that is why I want you guys to play. Yeah? I really get stressed out when I see you guys being very serious in the class. I want you to be serious, but your face should not reflect the stress. Because if you are learning math with stress, if you are looking worried, that gets me seriously worried. Okay? If you learn math with a smile, if you learn math in a playful way, trust me, nobody can beat you when it comes to scoring in maths. Yeah? Thank you. So, here we have learned so far congruence of triangles. We have learned about the properties of different types of shapes, perimeter, area. We have learned how to find out the area of rectangles, parallelograms. We learned about the 4 theorems of congruence. We also learned about area of a, no, we have not learned about area of a right angle triangle. Okay, so that's fine. We'll learn about it. Yeah. So now in the next class, we will learn about area of how is the area of parallelogram derived. You guys know that okay, area of parallelogram is base times height, but we will learn how the area of parallelogram derived, and then we will also learn something magical. You guys will not believe me, but something like this. If I have 2 parallel lines, if this is my base, let's say AB, this is my line segment. If I draw this, let's take this, or I draw this as 2 parallelograms. Let's say this is CD. Area of ABCD will be same as area of AEDF if these are parallelograms. So if you have same base and the parallelograms drawn between 2 same parallel lines, the area will be the same. So this, even if I am saying ABKL, this area will be same as this area, will be same as this area. That's what we will learn in the next class. Same way, if I have this base and I draw a parallel line, this area of this triangle will be same as area of this triangle. Will be same as area of this triangle. Okay? That is what we will learn in the upcoming classes. And that's why I was stressing so much on congruence of triangles. That's why I was forcing you guys to learn how is the congruence of triangle proved. Now this concept has gone deep inside your memory lane, right? When we come to this one, we'll be able to prove these things, and trust me, after this one, once you learn these things, you'll become a semi-teacher of geometry at least. you can literally toy with geometry, okay? You know what the formula is, and you also know how the formula is derived. I can guarantee you 90% of the students in high school also don't know how this is done. And you guys will be well ahead of them when it comes to this subject. Likewise, any topic, any subject, and anything that we learn in maths, we'll make sure that we learn it with the same level of conviction and authority, so that when you talk about it, nobody can doubt your depth of understanding, okay? If you learn it the way you understand it, you will play with it. Yes, Deekshita.
When are we going to learn the algebraic expressions?
Before anybody else in your class learns, okay? So we'll do it. So basically geometry, I'm thinking that I will probably wrap up geometry in maybe another one more week, okay? After that we'll put a pause to it, and then we'll, if you are saying algebra, we'll start with algebra. And we'll spend couple of months learning, playing, dancing with algebra, and then we'll go to trigonometry, then we'll go to other topics. Yeah?
Okay, sir.
Yeah? So I want you guys to play and dance with math, okay? That's my objective. If I get you to that level, my job becomes easier. Yes, Amoga? Yeah, Amoga, tell me, you are mute.
Are we going to do the algebra first and then go to algebra 1?
Yes, so this is where I need inputs from you guys, meaning, see, right now school has not started. Now when the school starts, you guys have to tell me what is that is being taught in the class or what you want to learn. If you just tell me 2 days in advance before the class, I'll make sure that I prepare the study material for you. Okay, I don't have anything defined as my priority. I will always teach it based on your priority. Okay, so if you guys tell me that this is what I want to learn in the next few classes, I will put that as a priority and I'll try teaching that in the simplest form so that it becomes your concept. Yeah. And for you, Amoga, since you are starting your high school soon, I'm just keeping you in this group for maybe another 2 more months, and as soon as I feel confident, I'll move you to level 3 so that you start dealing with the kids from high school, because I know Siddharth, Pranav, Deekshita and Sherry and many more kids, they are just starting their middle school, right? So they will go at a different pace when you might want to go at a different pace. Okay? So kids in my class, right, what I do is I will make sure that whenever I feel that there is a need for you to go to the next level, I will make you go there so that you keep enjoying the things that you learn. Because if I keep you in the same level, you'll end up finding that there are a lot of things that you already know. So that might not be the very good use of time. But yeah. But the core theme remains the same. Whatever you learn, you have to enjoy. I'll make you guys enjoy that. I'll make you do only enough assignment that keeps you excited about the topic. I mean, if I start giving you 5-page assignment with 50 sums, you will not enjoy it, okay? And that's not my purpose. Loading you guys with assignment is not my goal. I don't enjoy stressing you guys. I enjoy when I see you guys having fun with math, okay? That's my goal. Yeah? I see Deekshita is having fun already. Alright, so see you guys tomorrow, same time. We can wrap up for now and have a good evening.